Hello everyone and welcome to the channel. This is the second video, and as I promised, we are going to start this series on protocol buffers. So in this episode we are going to get an abstract introduction of what protocol buffers are and what area of technology or what application field does they fall in, also why they were invented and who they were invented by. So the shortest answer on this video would be who were they invented by, and it's a procedure invented by Google, and it is not a new technology per se, but the popularization has just happened in the recent version launch, which is the protocol version 3. Protocol buffer, also called protocol buffer, also referred to as proto. The proto version 3. So that has popularized because there has been some modern syntax improvements, and also the core idea, the compiler that is related to proto buffers has been improved vastly and has been ported to a lot of languages, bringing in excitement. And also Google's launch of gRPC, which is going to be something that we are going to cover in this series because that's highly correlated to protocol buffers, and it's a great application which Google is pushing out. So with that all said, let's get a quick introduction of what protocol buffers are and why they were in place for the beginning. So let me just quickly open up this drawing sheet, right? So for application standpoint, what are they used for, right? So what are they used for is basically data transfer on the web. Now historically we had solutions like SOAP, that was predecessor to JSON, and then we currently use JSON for almost all the data transfer on web what we do. So how does this basically the data transfer on web work? So basically what happens is the protocol that is used mostly is HTTP, right? So basically HTTP is the connection protocol which actually makes sure that data is being transferred, right? So that's an entirely different topic, but actually the data is transferred into binary form, right? Now the data is binary, right? So initially there was SOAP, right? Now SOAP was a structural and semantic format. What that means is that you had to define fields in a particular structure, right? Now SOAP was stopped, or SOAP was not liked actually that much initially as well, because it had a lot of restrictions in the sense that how you were writing that whole thing. Now, the problem with that is it avoids flexibility, and it is also giving people this strict rule that you have to do it like that. Now, think of two providers, right? You, the consumer, and some Stripe, say a third party service, which is the provider. Now, in this scenario, what you have to do is Stripe will provide you with a certain specific set rule, right? So this is the schema, this is the structure that you have to send your SOAP as, right? And also they used XML for the language choice, right? So that also made it hard for filing and also encoding data into that. So it was a mess, right? Then came ahead JSON. Now what JSON did differently is JSON was flexible from the outset. So there were no restrictions on how you wanted to put it out. How JSON got into popularization was that JavaScript was popularizing as a programming language on web. So it was no more the annoying language that gives you pop-ups and everything. So it brought in the concept of objects, and then the JavaScript object notation JSON was something that was derived from there. So the things that won the market for JSON were it was intuitive, okay, and it was simple, and it didn't require much into the transpiler time, so you could encode and decode data very quickly, and those were the things that were working in favor of that. But there are still some issues with using that. So one practical issue with using JSON in production apps or in scaled apps is that JSON is not JSON can't tell you if you are doing something wrong, right? Because it's unstructured. Just like JavaScript, if you declare a variable and you don't use it, there is no mechanism for it to tell you that okay, this doesn't exist. Same for JSON. If you spell a key wrong, say Stripe wants you to send your security key as security underscore key, right? If you spell it like security hyphen key, there is no mechanism in place that will tell you that you are doing it wrong. You can actually work on that, and this can get frustrating after a given point of time, because these bugs are subtle. What if you read in the documentation that okay, you know, at a base level, and you've been consuming APIs from 50 different vendors and 49 of them are using the hyphen, but just one is using the underscore, and it becomes unintuitive at that particular point of time, and these bugs can haunt you for days because you are not sure what the problem is. This is very similar to a typo problem in code. The bugs that are not logical take the most amount of time, then still there are transpilers and stuff like that in your code which can help you with debugging that okay, I did that wrong, or debuggers like that. But with JSON there is no tech like that, but and it can't even be built, because JSON again is an open and flexible protocol, right? You can send whatever keys you want to. It will never tell you that okay, you can't send this key, because you can. It's in the protocol, you can. It will never tell you that you can't do this, right? So what is the current problem right now is that JSON is too flexible for applications that are scaling beyond a certain point of time, right? So for companies like Google's and Facebook's of the world, the Netflix and Spotify's of the world, these problems become actual real big problems, because they are the consumers as well and they are the providers as well, right? Because they are providing their services via APIs as well, and they are also consuming services from various platforms, right? So for companies like that, this becomes a very big problem, right? So this was a problem for Google too, right? So what they thought is they wanted to solve this problem, and that's why they started investing in this idea of a technology called protocol buffers. Okay, and what protocol buffer is basically, it brings you the goodness of having strict type checking or strict semantics with reduction in size. So data size is also a very important factor while you are consuming data on the web, right? Network is one of the biggest. The term is bottleneck. So bottleneck is something that is reducing your capacity of performance, right? In a systems, the particular pain point that is reducing your system's capacity to perform to its limit is known as bottleneck. And in applications, specifically in web-based application, network is 90% of the times the bottleneck, because you don't know if your TCP connection will go through, or you don't know if the service that you are requesting data or sending data to is up or not, right? So network is a very unreliable asset in that manner, right? So the less amount of data you can send, also bandwidths are really big in this game, because if you are doing hundreds and thousands of requests, like a real-time stock market website or a data collecting website that is constantly changing its price, like a air ticket booking price application or something like that, the bandwidth becomes a really big issue. So the least amount of data that you can work with is the beneficial for the company as well as the user, because see, that will mean internally that the application will be faster. So for these two reasons, protocol buffers were invented, right? Now what protocol buffers do is, what they do is, you write a separate protofile. Okay, so you write a separate protofile that looks something like this, and what you say in your protofile is that okay, so consider message as a class, okay, or consider message as in JSON a key. Okay, now what you're essentially saying is, I want this to be required key, so I want this to be present every single time a person is created. Okay, the type of this name thing is going to be string, and this is the first key in when you are decoding my data. Okay, now required on the second is, I want this key to be required as well. It should be integer 32-bit type. The name is going to be ID, and when you're passing data, second key should be ID, right? Then there is optional, so basically it can be there, it can't be there. Okay, it's just like saying any, if you're coming from a strictly typed language that is written on a loosely typed language, something like TypeScript, that is a superset of JavaScript which allows you to take arbitrary input by using something like any, right? So it's very similar to that. It's giving you the flexibility of JSON, but it's also helping you with the idea that okay, you can actually structure this thing, and then we can apply further optimizations on this later. Okay, so how is this useful, right? So what brings the exact superpower to protocol buffers is that once you've written a proto file, right? So how does this function? What happens is basically, so let me just draw it real quick. So imagine this is your proto file, right? And these are the various systems. Okay. So these are some consumers and providers, right? And they are going to interact with each other. Now, the great thing about proto buffers is whatever the language choice of yours might be, once you've written the proto file in a standard.proto format that I just showed you, so this is a different format, right? You write a file in this format, and this is your data schema file, right? It defines what your data is going to look like. Now, once that's done, what Google also provides is a proto compiler. Okay, so what it does is basically provides you with a proto 3 compiler. Now, what does this proto compiler do for you? What it does is when you run this proto file in your system, like imagine a scenario where I am a service provider and you are my consumers, right? Now I can have 50 different consumers, right? What I need to do is now I have to write a JSON document or a documentation on my website which essentially explains every single key that I'm expecting and every single thing that I can send you, right? So the JSON description of my API that I have to write on my documentation. Once proto buffers, if you are using or if you are using proto buffers, what you need to do is you need to just provide your profile to your consumers. Okay, now imagine you are using, for say consumer one, you are consumer one and you are using Python for your language of choice, and there is a consumer two who is using JavaScript for their language of choice. Okay, now what you can both do is you can download your separate proto compilers. Okay, and proto compilers are written for system specific basis. So Linux, there is a one proto compiler. Then if you are using some single core CPU like Arduino or something, then there is also a compiler, and there is a compiler for Windows and there is a compiler for Mac, right? So once you've downloaded your compiler for your system, what you can do is you can compile this proto file in whatever language you're working with. So for consumer one, you can compile that file into a Python file, okay? And for consumer two, you can compile that in a JavaScript file. Now, what is this compiler going to yield? This compiler is going to yield a object-oriented class-based structure which defines your data. Okay, so basically it's going to lead to a class that will have getters and setters methods, which we'll see in the next video when we are going to do this practically. We are going to completely do analysis on the size and everything. So what's that compiler is going to do is it's going to compile that proto file into the language of your choice, and it's going to have getters and setters methods. Now once you have getter and setter methods, if you are supposed to send me data, then what you do is you just create an object and use the setter methods to set the files. Then there are methods to serialize and deserialize. Okay, now once you serialize it, all things are binary and you can send the data on the wire as you want to. Once I received the data and say my language of choice is JavaScript, I deserialize the data, and I can, once I've deserialized the data, I've already got an object. Now how do I interact with that object? Remember, I have that also class compiled for me too, right? So once I've got that object, I already got those getter methods with it, right? So once I load that data into my class instance, I can use getter methods to get the data out. Now Google also shows a good example of it here. So imagine this being some arbitrary language. Okay, they compiled it. Now what they do is once they compile this in this language, they get this person, then they build an object for it, and then they have setter methods so that they can set files. Now for output, they just take this and write it. Okay, for reading it, once they've read it, they actually get an object right here, right? So on that object you have getter methods as well. This is the power. This is the actual core principle power, what makes protocol buffers great. Once you've written a proto file, all your consumers can download your proto file and compile it for their language choice. There is all the platform benefits of having a serialized data that is just binary, and it's actually the smallest binary that can be generated, because the compiler, when serializing data, also optimizes the data so that you are only storing the minimum amount of data, and once you send that to the wire, it's lighter, it consumes less bandwidth, and it's faster in return. So that's why protocol buffers are really useful. Now, basically, that is the core idea of protocol buffers. Now, Google is building this thing called gRPC around this protocol buffer idea, because they already have a messaging protocol. Now, what they are trying to do is they are also trying to speed up the RPC protocol. So the remote procedure protocol, that is basically like doing API call, but the sense you get a function that is executed on remote machine, and you just provide it with arguments. Say in the case of Stripe gives you a checkout function, and you provide that, okay, I want to charge this person 13 rupees 55 paisa, right? Then you just pass in that, and Stripe does the rest on their machine for you. So that was an introduction, quick introduction to protocol buffers. And in the next video, what I want to do is I want to dive deep into this practically, and we are going to write an example in Node, I guess, and also consume that in Python. And what we are going to do is we are going to see, download first of all the protocol compiler, and then we are going to build a proto file which is going to be shared between our Node and Python application. And with Node we are going to serialize that, and with Python we will deserialize it, so that the protocol buffer concept is strengthened and we can have the knowledge to practically work with it. So on that note, thank you so much for watching this video, and I hope to see you in the next one.